Geometric sequence is a list of numbers with a common ratio. So something different than those arithmetic sequences is that we're going to be multiplying instead of adding each time. These are going to go hand in hand with the exponential functions, just like the arithmetic sequences went hand in hand with the linear functions. So down at the bottom, we're looking for a common ratio, not a common difference like we had with arithmetic sequences, but a common ratio, what we're multiplying by each time. So what are we multiplying to get from 3 to 4 and then from 12 to 48? That would be r equals 4. Over here, it looks like we're dividing by something. Looks like we're dividing by 2. But when you write your ratio, you have to write it in terms of what you're multiplying by, not dividing. So that would be r equals 1/2 is what you're multiplying by. We got an explicit and a recursive just like we had with arithmetic sequences. On the explicit, we've got the first term times the ratio raised to the n minus 1 power. You know, on that last one, the arithmetic sequences, we had difference times n minus 1. On geometric sequences, we got r raised to the n minus 1. Recursive, we've got our common ratio times the previous term, that a sub n minus 1 again. So first term is 5. And my ratio, what am I multiplying by each time? Well, 5 times 2 would give me 10. If I can't figure that out, or if I've got some weird decimal, or, I just don't know what it is, I can take any term, let's say 40, and divide by that term, the previous term, and it will give me what my ratio is. So 40 divided by 20 will give me 2. So my explicit formula, I've got a sub n equals the first term, so a sub 1 times the ratio to the n minus 1. So for this one, it would be a sub n equals 5 times 2 to the n minus 1. If I wanted to know the fifth term, just like with arithmetic sequences, I would plug in 5 for n, so I'll have 5 times 2 to the 5 minus 1 power. And, if I'm looking for the fifth term, that's pretty easy up here. I'm multiplying by 2, multiplying by 2, multiply by 2, multiply by 2. That's going to give me 80. But as a general reference, if you're searching for a sub 10 or a sub 15 or something like that, oftentimes it's going to be easier to punch in to the explicit formula, because if it's some weird decimal or something, you're not going to be able to do that in your head. More than likely. Recursive formula, I've got a sub n equals the ratio times a sub n minus 1. The ratio in this case is 2. And sometimes people write that with parentheses. Sometimes people write it with just a dot for multiplication. This time I'll write it with a dot, and then the next time I write it with parentheses. So my first term is 5. Next, first term's 1. What am I multiplying by each time? Looks like I'm multiplying by 3. The explicit would be a sub n equals the first term, 1, times 3 to the n minus 1. Now, that whole please excuse my dear Aunt Sally right here, I can't make this 10 because I have this exponent attached to this thing. I can't say that 10. That's 5 times 2 to the n minus 1. Here, I have 1 times something, and 1 times anything is going to be anything. So I could simplify that to make that, say, 3 to the n minus 1. A sub 5, I would just plug that in to the explicit formula, so that'd be 3 to the 5 minus 1 power. That would be 81, I think. 81. Recursive formula would be a sub n equals the ratio, 3, times a sub n minus 1, with the first term being 1. This one I've got a first term of 100 and a ratio of, what am I multiplying by? Well, I'm dividing here. Dividing by 5. The way that you write that in terms of multiplication is you're multiplying by 1/5 each time. So the explicit form would be a sub n equals the ratio. No, excuse me. The first term, 100, times the ratio to the n minus 1 power. If I wanted to know the fifth term in that sequence, I would plug in 5 to the explicit formula. That'd be to the 5 minus 1. And I think that would be 0.16. recursive form, a sub n equals the ratio times a sub n minus 1 with a first term of 100. Next, first thing I notice here is that the signs are alternating. I got positive 10 and then negative 20, and a positive number, then a negative number, positive, negative, positive, negative. And that just tells me that my ratio is going to be negative. So from here to here, what did I multiply by? Negative 2. And if you didn't know that, you could take negative 20 and divide by 10. That would tell you negative 2. And then negative 2 times negative 20 would be positive 40 times negative 2, negative 80 times negative 2. That's going to tell me my fifth term down here is going to be, what, positive 160? 160 down here. Explicit form, I've got a sub n equals the first term times the ratio to the n minus 1. And I could plug in 5 for the fifth term right there. And give me 160. The recursive is the, man, I keep doing that. The ratio times a sub n minus 1, and a sub 1 is 10. This one I'm given the explicit formula. I got to find the rest of it. So knowing the explicit formula, that's my first term right here. And that's my ratio. First term's right there. And my ratio is what I'm multiplying by each time. So 40 times negative 1/2 is going to be negative 20 times negative 1/2 is going to be positive 10 times negative 1/2 will be negative 5. And if I want to know the fifth term, I'm going to plug in 5 right there. That'd be 40 negative 0.05 to the 5 minus 1. And I think that's going to give you positive 2.5. Recursive form, I'd have a sub n equals the ratio times the previous term with the first term starting at 40. Lastly, I got the first term right here. Please don't miss that. This is my ratio, 3. So the first term is 6, and I'm going to multiply that by 3, and that's going to give me 18 times 3 is 54 times 3 is 162. And if I wanted to write the explicit formula, that would be a sub n equals the first term times the ratio to the n minus 1 power. And the fifth term would be 6 times 3 to the 5 minus 1 power, which I think is going to give you 486.